Another thing is that some ethers can undergo Claisen rearrangement. So let's take a look at what that is. So we have some kind of alkene here with some kind of substituents. We have some kind of ether that's also next to another alkene. And if we heat this, this will undergo a Claisen rearrangement. So whoops, should be down here. This will undergo a Claisen rearrangement where this pi bond is going to jump over here. This sigma bond is going to become a pi bond to form a carbonyl. And then this pi bond is going to jump over here to form a sigma bond between these two carbons. So your end product is your R1 is over here. Now you've got the carbonyl, R2 over here. And then you've got this component over here, right? Where this pi bond came from the green arrow. This sigma bond came from the pi bond from that orange arrow. And then this pi bond came from the pi bond from the purple arrow. This is a one-step pericyclic reaction, right? So this is this all occurs in basically just one go. And what you need here is an allylic, vinylic ether, right? So what does that mean? Let's go ahead and draw it out. So your allylic means that we're next to a pi bond, right? Your ether is next to a pi bond. It's not directly attached to the pi bond. It's on a carbon next to the pi bond. Whereas the vinylic means that it's directly attached to the pi bond. So we'll say on pi bond. This is relatively common with benzene rings. So if we've got a benzene ring and something like this, you'll notice that we have the motifs, right? We have the allylic part right here, the vinylic part right over here. I'm going to move this pi bond over here. It's the same thing though, but just for clarification. Right, that one over there. And so we can bounce this pi bond over here to form a sigma bond, bounce this pi bond up here to form another pi bond, and then bounce this sigma bond to become a carbonyl pi bond. And then what you get is this intermediate right here. Right, where this blue one came from the blue arrow, this one came from the orange arrow, and then this one came from the purple arrow. In this case, though, we've got a ketone that will quickly tautomerize to an alcohol, in this case, phenol, right? So remember when you've got the ketone and the alcohol next to a pi bond, they can tautomerize back and forth. In this case, because it can form phenol, it'll actually tautomerize towards the phenol and not the ketone. So look back on the tautomerization section of how this occurs.